20 acres of covered production and about 6 acres of outdoor production. The whole property is about 110 acres though. You know, we've been here, we produce plugs, rooted cuttings, bedding plants, potted crops. Because we're a plug producer, we do about 5,000 different varieties of plants. Yeah. We do all kinds of perennials, we do all kinds of annuals. Then we have a complete vegetable listing. We probably list 200 different types of tomatoes that we offer and peppers because we're doing specialty varieties for the local farmers. Right now we don't use recycling, and the reason we don't is, as I mentioned earlier, there's a lot of different ways to go about watering. One of which is to reduce the amount of water you put on initially, so you have no runoff. And that's basically the method that we've used. So we're what we call a very dry grower. So if we're watering a particular plant, either through drip irrigation or by a hose, we only put enough water on that plant so that it can get to the next day. All of our water comes from wells. We have 4 wells on the property. They're about 110 feet deep each. They're capable of producing about 100 gallons a minute, each well. The water is coming out of our wells. We have 1, 2, 3, 4 wells. This number one well is what we call our lead or master well. And it's connected to a control panel down there. And one of the things that we want to accomplish is we want to provide a very constant and steady PSI, or water pressure, throughout the entire facility. And the control box down there actually accomplishes that. So we basically say we want 85 PSI at that box over there, 24 hours a day, 7 days a week. This is the control panel right here. So the control panel basically, and I'm pretty sure it creates a DC current. It takes AC power, converts it to DC, and that's what creates that positive and negative situation. What that unit is doing is constantly monitoring the pressure, the usage, and varying the frequency of the electricity, which varies the speed of the motor. So we measure the amount of time each pump is running. And because we know that there's a correlation between GPM and pump time, we can extrapolate how many gallons per month and how many gallons per year that we pump. Our water just happens to be very good for growing. We have very low salt, very low calcium, very low magnesium. The only element that's a bit of a problem is iron. Iron in our water, it also tends to precipitate out inside these tanks. As a result, they get what we call a green slime on them. So we take them out once a month and we power wash them so we keep the efficiency of the system going. And it's accomplished using what's called a motor frequency drive. And that drive controls this pump. Now the reason I mention this is because this pump is always running, but it isn't always pumping water. And the way this system works is it varies the frequency of the electricity to the pump. And by doing that, you can vary the speed or rotation of the pump, which therefore varies the amount of water. So this well is capable of producing about 70 to 80 gallons a minute. But if you reduce the hertz of the electricity to 40 cycles per second, this only pressurizes, it doesn't pump. And so when there's no demand for water, this will hum along at 42 hertz. And the reason I mention all that is because then this is constantly diverting water through these 2 tanks. So these are your copper ionization tanks. And in here are copper bars that are electrified with a current. And that current is what creates the ability of the copper ions to release from the copper and get into the water. The copper we're putting in for a number of reasons. The copper is an element, as you know, that controls the bacteria and things like algae. So in our misting and propagation areas, because the humidity level is so high all the time, we were finding a lot of algae growth on the floor of the greenhouse. Adding the copper cuts way down on that algae. Also, we saw a correspondence to when we put the copper ionization in to a reduction in loss during the propagation of rooted cuttings. This is a brand new, pure copper bar. They disintegrate. So look at this. This is a used bar. Yep. So this just disintegrates or flakes off, and look at this one. Just completely. But the copper tanks and bars, I think it cost us about $15,000 to put in this for the whole system. We've had it for about 10 years. If the copper ionization is not working, the algae that grows on the floor of the greenhouse is rampant. As you use it, you keep it suppressed. So we know it's working. So it's directly connected to the pumping system. And a pump comes on, the copper ionization comes on. No, it was just found that you got to get up around 2 parts per million to really kill all the pathogens that can affect your plants. Unfortunately, at 2 parts per million, you also start to get toxic levels to certain plants. And so we're not going at 2 parts per million, we're trying to put 1 part per million in. But because our water is so pure, we have a hard time getting the amount of copper into our water that we need. The ionization process has to occur because of you're having a level of EC. So our water has almost no EC. So because of that, electroconductivity. So there's no exchange of ions between the water. There's nothing to grab the copper ions and put it into the water. Now, we've talked about fixing that. One simple thing would be to put a very dilute solution of fertilizer in prior to the copper ionization. You just added EC. But we've been leery of doing that because now that means you've added this feed to everything. Anytime there's a call for water, this is on. And even if there isn't a call for water, this is on. And that way we're constantly, there's never a time when non-ionized water is going into the greenhouse. And we feel that's kind of very important to keeping everything clean. And I'll show you the bars. I think they're down in the shop. Our water is almost 6.9. That's something else that we do. We measure the alkalinity and pH of our water every week coming out of the wells. So a lot to it. Water management is very important. You know, we're very careful about making sure that what little runs out of the greenhouse is cleaned up before it, goes off the property. I think we've been very happy with the copper. It isn't the cure-all. As I've said before, the ozone system is probably the most effective, but it's also the most expensive. If you have a serious water problem, then that's probably the way to go. For our application, this is the best way to go. Most cost effective, does what we need it to do, but doesn't cost us a fortune to do it.